this video, we're talking about how to graph linear inequalities. And when we talk about linear inequalities, there's two things that we're putting in there, right? Linear and inequality. Well, we know it's an inequality if this is not an equal sign, if it's either greater than, less than, greater than or equal to, or less than or equal to. The fact that this is not y equals -1/2 x plus 1 means that it's an inequality, not an equality, because y is not equal to this right-hand side. So it's an inequality, and we call it a linear inequality because both of our variables, x and y, are linear variables, meaning they are first-degree variables. We have essentially here y to the first power and x to the first power, as opposed to having an x squared or an x cubed involved in our inequality. We have just x and y, so it's a linear inequality. That means the graph of this inequality is going to be a line because it's linear, so we need to go ahead and graph the line. How are we going to do that? Well, in order to graph the line, we're actually going to treat this more like an equality than we would an inequality, or I could say we're going to treat it the same way we would as an equality. So if we said instead of y greater than -1/2 x plus 1, if we said y equals -1/2 x plus 1, we can easily graph this line if we remember that the slope-intercept form of a line is y equals mx plus b. When our line's in this form, remember that b is the point where the graph intersects the y-axis, and m here is the slope of the line. And the fact that we're dealing with an inequality here, y greater than this value, doesn't affect our ability to apply this slope-intercept formula for the equation of a line. In other words, just because we have a greater than sign instead of an equal sign doesn't mean that we can't call this the slope of our line. It doesn't mean that we can't call this the y-intercept of our line. So we're going to go ahead and plug these values in. The y-intercept is going to be +1, so that means +1 along the y-axis here, and the slope is -1/2. And remember, that means that we're going to go down 1 because we have this -1, so we're going to go down 1 along the y-axis, divided by +2, so out to the right in the positive direction of the x-axis, 2 units. So we're going to go down and plot that point, then we're going to go down 1 and over 2, and plot this point. Here we can go up 1 and to the left 2. We can go in the opposite direction, up 1 and to the left 2. So we have these points here that form our line, and now we just need to connect the points. But this is where we have to pay attention. Because we have y greater than -1/2 x plus 1, because we have this greater than sign, we know we're going to have a dashed line, right? A broken line like this. So we can connect the points this way with a dashed line like this. And now we say this inequality is basically telling us that we want all the space that's above the line -1/2 x plus 1. So because we want all the space that's above it, we go ahead and shade in all of the space that's above our line like this. This would be the graph of the inequality, and just keep in mind here that if you have a greater than sign like we just did, you'll do a dashed line and you'll shade in the space above it. If you have a less than sign, you'll do a dashed line and shade in the space below it because you're shading in everything that's less than this line. If you have a greater than or equal sign, it means you're going to do a solid line instead of a dashed line, because this equal sign under the greater than means you're including everything above the line and everything on the line. So you do a solid line instead of a dashed line, and then you shade in everything above the solid line. And similarly here, if you have a less than or equal sign, you do a solid line because this equal sign indicates that you have to include everything on the line, but you also want everything less than it, so you shade in everything underneath the solid line. And that's it. That's how you graph a linear inequality.